Hello, and welcome back to elementary algebra from quarantine, I guess. So, the goal for today is to go through the section on the 4.2, last section in chapter 4, which is the one on solving the systems. And the previous lecture, 4.1, was solving systems using graphical approach. Now we are going to do the solution using the system of equation solved by substitution method, which is algebraically, which is where you get to calculate x's and y's. So let's take a look at a couple of those examples, the way the method works. And then the homework will be posted. You guys can go and practice, and that will be it. So if we have a system of two equations, say you have the good old ax plus by equals c and dx plus ey equals, let's say, f. These two equations together are called system of linear equations. And the system of linear equations can be solved using graphical approach, which was 4.1, substitution, which is what you're learning now. And then there is also elimination method. You can use matrices and a whole bunch of other stuff later on. But now we're focusing on substitution method. Now, the way the substitution method works is you will have to solve one of the equations for either x or y and substitute that equation into another equation. So, use substitution. Solve for x or y in one of the equations and substitute, I'll say also plug in, into the other equation. Now, we can still have three different solutions. We can also say answers, whatever. Number one, single solution. That's what you actually get x, y as a point. And two, we can have no solution. We'll see that you will get something like a is not equal to b. We'll get there. And three, infinite solution, which is, I'll say a equals a, and that will make sure. I see some of you are making it to the chat. So let's take a look at the first example. Say I have a system of equations where one equation is given as 2x plus y equals 10, and the second equation is y equals 3x. That's it. So this is our system. So we are going to now see that the second equation has this solved for y, right? So that means that y is equal to 3x, and I can plug that in here, right? So that's the idea. Plug in or substitute. So that's the idea. You solve one equation for x or y, and you plug that in into another equation. So we are going to get from this equation 2x plus 3x equals to 10. And this 3x was your old y, because y is 3x. So we are replacing y with 3x. That was the idea. Now if you look at your new equation here, well, it only has x's. We have 5x equals 10. When we divide both sides by 5, x is equal to 2, and we have our x. So the goal is to combine two equations into a single equation and at the same time eliminate one of the variables. And we can solve it because it will be a basic equation. Once we have x, now we need y. Well, we know that y equals 3x, which means 3 times 2, which is 6. And finally, we have 2, 6 as our solution. So solution is the unique solution, one solution, right? 1 point. And we can quickly check that solution, the same like we did the last time, when you plug in 2, 6 into both equations. So 2 times x, which is 2, plus y, which is 6, is 4 plus 6, which is 10. Good. And y is 6, which is equal to 3 times x is 2. 6 equals 6. That's good as well. So it worked in both equations. Therefore, 2, 6 is a solution. So let's take a look at another example. We'll do a couple of examples, obviously, here in the lecture part, and then you guys should do this in homework, which I will post immediately. So here is another case where we can have the negative 3x plus y equals negative 10. Second equation is already solved for us, so we should say thank you, right? Y equals x minus 2. So negative 3x plus y equals negative 10, and y equals x minus 2. So this is our system that we are supposed to solve. Well, y is already x minus 2, so we need to plug that in for y. So from this equation, we have negative 3x plus, and instead of y, I have x minus 2. And then equals to negative 10. So please note that these two equations are the same equation, except the y is replaced what y is from the second equation. That's the idea. Now if you look at your equation here, minus 3x plus x is minus 2x. Minus 2 equals negative 10. Add 2 to both sides. Now it's a basic equation. Get negative 8. And when I divide both sides by negative 2, x is 4. So we were able to calculate x. Now we need y. We have that y is equal to x minus 2, which is 4 minus 2, which is 2. And we have our solution 4, 2. So that's the procedure. That's the procedure to figure these things out. We can also check real quick. -3 times x, which is 4, plus y, which is 2, should be -10. -12 plus 2 should be -10. -10 equals -10. And it works. Now we are going to check the second equation. Second equation is y, which is 2, needs to be 4 minus 2. And yeah, 2 equals 2. Good. We got both of these to be correct. Therefore, we're done, right? The next case is a little bit trickier because you will have to do some work to fish out your equation. Let me show you what I mean. 2x minus 3y equals -4, and 3x minus y equals 1. So with this system, we have a little bit of a problem. We do not have equation given as x equals or y equals. We have to make it. And as you can see, the easiest one to go for is whatever has a single y or a single x, and in this case with the coefficient either 1 or -1. So in this case, that will be this y over here. So now the first step is solve for x or y in any of the equations. See, previous two problems gave us already solved. So previous two problems were easy. You just plug in and you're done, right? Now, we have to solve, in this case, for y in the second equation, because that is the easiest of all of them. So, from the second equation, we are going to remove 3x. We'll get -y equals 1 minus 3x. And then we have to divide everywhere by -1 to make y positive. And we'll get -1 plus 3x because -1 only changes signs. Now, if you want to be fancy, right, you will write 3x minus 1. Remember that the signs in front of the coefficients, in front of the numbers, belong to that number. So positive stays with the 3 and negative stays with the 1 as you swap their places. Remember what we did in class, right? When I said you have the box, right? And there is a number 3, and then you have another one over here, right? Which has a -3. Well, you can swap their order, right? You can physically pick up a box that is -3 and put it in front of 3, right? So the sign numbers, right? So we are allowed, using commutative rule, to swap these two. So now we have an equation that it's y equals, and we can take that y and plug it into the other equation that we didn't use yet. That's where it goes. So, actually, let me change the color over here to purple. Plug it there. So what do I have? I have 2x minus 3 times, open parenthesis, here's your purple 3x minus 1, and equals to negative 4. So as you can see, the first equation and this equation, it's the same equation. Just the y is replaced with what y is. Once we have that, we are going to say 2x minus 9x plus 3, because this negative 3 needs to be distributed to both of the members in the parenthesis. And that's equal to negative 4. So now, 2 minus 9, that's negative 7x, plus 3 equals negative 4, minus 3 on both sides. Negative 7x is equal to negative 7, because minus 4 minus 3 is negative 7. And then we are going to divide both sides by negative 7, and that will give us x equals 1. Now we need y. Well, luckily, we have equation for y right there. So y is equal to 3 times x, which is 1, minus 1. Y is equal to 3 minus 1 equals to 2. And we have our solution 1, 2. You have to put this as a point, because remember, solution is the intersection of the two lines. And two lines intersect at the point that has x, y. So we are going to present the solution to the system as ordered pair x, y. And I'll just put here, in interest of time, need to check in both equations. Need to check in both equations. And the reason is, right, we want to make sure that the problem is correct. So one more time, this is a little bit longer than the previous one, but we can still, right, power through. Your job is to look at the problem and locate which of the 4 has coefficient of 1 or negative 1. Which one is single, right? You have 2 x's and then 3 y's and then 3 x's, and there it is, a single y in a second row. We solve for that y. That's why we had that problem on the first exam where you guys had to solve for x or solve for y and so on, and we practiced that. It was in chapter 2, I believe. So we use that skill here to solve for a single variable. And once we have the equation, either x equals or y equals, then we bring that and plug in the other equation. That will give us an equation with only one variable, and you would be able to solve that equation for that variable at the end. In this case, we got x is 1. Then you bring that x into the y equation to solve for y, and you're all set. When you're checking, please make sure you check in both equations. Now, the next example will have your favorite F word in it, which is obviously fractions. So some problems will have fractions, like problem 16. It says 3/4 x plus 1/4 y is negative 7/4. And they were really nice and already solved this for x. X equals 1 minus 2y. Wow, what a nice folks, right? They're really nice. So all we need to do now is to deal with the fraction. But we already know how to kill a fraction. We multiply by common denominator, and in this case, that's just 4. All denominators are 4. So we are going to multiply every single one by 4, and you know what? All of the 4s will just cancel. So we will have a new system now, which will say 3x plus 1y, which is just y, equals negative 7, and x equals 1 minus 2y as the second equation. No more fractions. So that's the power of the common denominator, right? So we are going to now plug the x value, which we have over here, into the x value here to solve this particular problem. And the whole problem now will be in terms of y. So this equation now becomes 3 times, oh, I forgot I wanted to do this purple. There we go. So there we go. So 3 times we have 1 minus 2y, and then we copy the rest, which is plus y equals negative 7. Again, these two equations are the same equation. They look a little bit different, but they are the same equation. So you are going to solve this now. We distribute, right? We get 3 minus 6y plus y equals to negative 7. And now we're going to have 3 minus 5y equals to negative 7 because we have the, we combine negative 6 plus 1. That's going to give us negative 5. And now we're going to take 3 away on both sides. We get negative 5y equals to negative 10. And we divide both sides by negative 5. Y equals 2. Divide negative by negative, you get a positive, right? So we calculated y this time. We need x now. Well, luckily we have the equation that we can use to get x. So x is equal to 1 minus 2 times 2, which is 1 minus 4, which is negative 3. We have to list x component first. So the answer is negative 3, 2. That's one of the common mistakes, right? Make sure you always list x first. X is always first. One of the common mistakes you guys make is you do all of this correctly and then you put y first because that's the number you found first. No. Make sure you always put x first because all of the ordered pairs are always written as x, y. I understand we calculated x second, but that's okay. We don't care. We care that the numbers have to be, the ordered pair has to be represented as x first and then y second. Therefore, negative 3 is first and y is second. Let's take a look at one more exercise, and then we can take a look at a word problem or something. So let's say we have a system. Let's find another system. What should we do now? We can do a couple of these, but how about this? 5x plus y equals 4, and 5x plus y equals 3. Very simple system, right? When you look at it. Almost the same, but not quite. Very easy to solve for y, right? Take 5x on both sides. So y equals 4 minus 5x. When you subtract 5x to get y alone. And now you take that and you plug it into y. So what do we get? We get 5x plus, and now we have our 4 minus 5x, and we have equals to 3. Now look what happens. When you remove the parentheses, you get 5x minus 5x cancels out. And you are left with this 4 not equal to 3. Now remember what that meant when we started the lecture? All the way up I said you can have 3 different types of solutions. Look at the second one. That's what it means. If you get 3 equals to 4, or you get 7 equals to a half, or whatever, you get some nonsense like that, right? It's not mathematically correct to claim that 3 is equal to 4. If you get something like that, then you have no solution. So we have no solution, and we go and we just write. We have to write it because that's the answer to the question. You have to write no solution. This is the one that we box and present for the full credit, right? If you just write 4 equals to 3, or right, or you get confused with that or something, that doesn't count, right? We have to write no solution because that is our way of stating that there isn't a pair of numbers, x and a y, that can make this work ever. And that should be kind of common sense, because anytime when you pick x and a y, and when they make a 4, they cannot make 3 at the same time. That's something that we call uniqueness, right, of the answer. So they're either making a 3 or they're making a 4. They can't make both of them. So that's that part. So that was a really cool problem for no solution. Let's see if we can find something else. Ooh, how about this? 2x minus y equals to 6, and 6x minus 3y equals, let's say, 18. And let's say this is a system. Well, we are looking for y by itself, so negative y is equal to 6 minus 2x. We take away 2x on both sides, trying to get y alone. Divide both sides by negative 1 and get y equals negative 6 plus 2x. And just to flex a little bit, put 2x minus 6, it's better, right? So now we take our y and we plug it in for y. Let's see what happens. So 6x minus 3 times, open parenthesis, 2x minus 6 equals to 18. this is what we get. Now we distribute negative 3. That's going to be 6x minus 6x plus 18 equals 18. And now you see that these two cancel. So now we have 18 equals 18. Now that's a true statement. So what now? This is that third case when you have infinitely many solutions. Infinitely many solutions. And this is what you get to box. That is your answer. So now you have seen all three possible answers that you can get when you solve the systems of equation using substitution or any other method. You can have a single solution where you have x and a y. You can have no solution when you get some garbage like 3 equals to 4, right? And then you have to say, well, that's never true. And the third one is infinitely many solutions when you get a correct statement. You know, you can get 7 equals 7, you can get 10 equals 10. And in this case, we have 18 equals 18, so there will be infinitely many solutions. So now, let's take a look at one of the word problems to see what the word problems are like in this case. Now we can take a look at a whole bunch of problems here. I'm trying to stay away from 57. All right. So we're going to take a look. I'm just going to rearrange stuff over here. Okay. So we are going to take a look at a problem that lists average room prices in 2013 and 2012. So average room prices in 2013, oh, this is problem 57 in the textbook. So in 2013, the average room price for a hotel in Cancun, Mexico was 30 more than it was in 2012. So in 2000, price of the room was by 30 more than in 2012. Now, here's this fun one. The 2012 room price was 86.4%. I know, but 86.4% of the 2013 price. Figure out equations, figure out the price. Find, well, maybe write equations, and B, find prices in 2012 and 2013. Cool. So we have a word problem now that you could be figured out with for other stuff as well, not just room prices in Cancun. And you can apply this problem literally for anything. So we can first define our variables. I'm going to put that in red because it's very important to define variables. Define variables. So price in 2012 we can call that x, and price in 2013, we can call that y. So we have to start somewhere, and defining our variables is extremely important. So we define a variable, and then we go on and deal with the rest. So let's go and first read this problem again, so we can write the equations. First sentence is going to give us first equation. First sentence is going to give us first equation. So in 2013, the price of the room was by 30 more, right? By 30 more. So what we do here is we write the equation. We write the equation by saying in 2013, well, 2013, that's a y. The price of the room was 30 more than in 2012. So that has to be x plus 30. X plus 30. So what we can do now is write the second equation. So the 2012 room price, well, that's x. That is going to be 86% of the 2013. Now, the word of in mathematics, in word problems, is made by the multiplication, right? Of means multiplication. So we make the percents into a decimal. So that's something else that you know from before, that 86.4% is written as 0.864. That is very important because we have to use decimals in our equation. So all I need to do is to say 0.864y. So let's look at the second equation for the second sentence. So one more time, the price in 2012 is 86.4% of y, which is the price in 2013. These are translated directly. If you know all of the mathematical symbols and you define your variables, you're just going to go literally word by word and translate the English statement into mathematical statement, which is equation. So that's all we do. And now look what I have. I have two equations with two unknown quantities. All I need to do is to plug in. It's already solved for x over here. We can just plug that in there and be done. Y equals 0.864y plus 30 . We need to subtract to put y's together, right? You have a 1y on the left and 0.864y's on the right. So we're going to subtract 0.864y on both sides. They will cancel on the right. On the left, you will have 0.136y, right? That's 1 minus 0.864. And on the right-hand side, you have 30. Divide both sides by 0.136. Now for this we're going to cheat with a calculator, obviously, right? It can be done by hand as well. Both numbers are Right, you multiply by 1,000, do the long division and so on, but 30 divided by 0.136 is going to give us y equals 220 and 59. Now you're going to get a lot of decimals here, but remember, money has 2 decimal places only because it is cents. So we only get to keep 2 decimal values, and when we round 588 up, right, we'll round it to 0.59. So we have a y. We take that y, so now need x, right? Need x. We plug that back in there. X is equal to 0.864 times 220.59. So now we have to calculate that value. So 0.864 times 220.59 gives us x equals 190 point, again 2 decimals, so 59. As I mentioned in class, you are supposed to provide sentence answer for every word problem. So we're going to say price of the room in 2012 was 190.59 cents, and in 2013 was 220 and 59 cents. This is your answer. This is what you box, the sentence, because that gives you points. If you don't have a word for a word problem, if you do not have a sentence answer, you are automatically losing points. A minimum of 2, right? If something is wrong, then it's more, right? So we need to provide a sentence answer for the word problem. Let's do another word problem because we love these word problems so much. Should we do mixture or real estate, exercise and calories? Type something. Give me something to work with. Mixture problem, real estate, exercise and calories. What would you like to see? Calories. All right. Let's go. So problem, there are 2 problems. 69 has calories and 70 has exercise with running. So we'll go with the 69 because that one has calories rather than and also, aren't we all consuming now extra calories because it's it's crisis situation, so everyone is stress eating like 17 meals a day and sleeps 3 times a day and watches 4 movies a day, and it's still the same day. Didn't you notice that? Yeah, the day is wide open, huh? Anyway, so now we're going to have algebra also 3 hours a day, and then it's just going to be great. All right, let's go and see what problem 69. So this is for the calories, page 278. Yeah, this is what you should be writing stuff, but that's okay. I mean, popcorn, put me on on a TV, right? You have a smart TV connected to the internet. Put me up on a 50-inch in a living room, and the whole family has to suffer through this. Every day at 3 p.m., everyone will be running for their lives. Algebra class time. All right, so let's go talk about calories. So in a 48-minute workout, a student, this is where you plug in your name because you want to care. A student burns 450 calories. On a tread climber and stationary bicycle. Now, there are two different exercises that are done. So 48-minute workout, 450 calories burned, but there are two different exercises. Exercise number one is called tread climber. And that one burns 12 calories per minute. Exercise number 2 is a stationary bicycle. That's the one you get, you use and you get nowhere, right? After the use. So stationary, that one is 5 calories. See, I told you. 5 calories per minute. All right. So how many calories are burned with each of the exercises? That's what we want to know, right? So how many calories are burned with each exercise? Cool. We are going to set up a chart just like we did in the class at one point. I remember I talked about the charts. So we are going to set up a chart that will have calories and time and exercises. So we're going to set up a chart like this, where we're going to have tread climber, that's exercise 1, and then stationary bicycle, and then we have a total column here. Why am I writing a chart? You don't actually have to. Sure. We have a volunteer to solve this on the board. I love it. Thank you. That makes my day, actually. So we are setting up a chart to organize this mess of information that is given to us. If you are able to solve this without the chart, that's fine. You are not graded on a chart. You are graded on that sentence that you write in the end, which will state how many calories was burnt by each one of these. So what I'm going to have here is time, because that's the time I was on each one of these exercises. And then I will have how many calories per minute So actually time, let's put minutes here. So minutes, and then calories per minute, and then this will be the total of calories, right? Because when you multiply and equal, you see minutes cancel minutes, because 1 minute are in the denominator, the other one is in the numerator, so they would cancel, and you just get calories equal calories. Cool. I don't know how long I was on the first exercise, so I will call that X. I don't know how long I was on the second exercise, I will call that Y. But I know that a total 48 minutes was spent exercising. So X plus Y equals 48 would be our first equation, because that's the total time. X plus Y equals 48 is our first equation. Very simple, right? Because we have the total time of 48. Now, the first exercise burns 12 calories per minute. The second exercise on a stationary bicycle burns 5. And if you take a look of the top over here, it tells you how to get these cells at the end. This is 12x, and this is 5y. Because you are supposed to multiply them. But the total amount of calories you burned was 450. And this is where the other equation is. Again, if you can do this the other way, any other way, that's okay. Chart tends to be one of those systematic ways to solve this. So here is your addition. Here is your addition. Right? So when you add these equals the number, which is the total number on the bottom. So x plus y is 48, that's the time equation, and 12x plus y equals 450 is your calorie equation. And now we can just ignore everything and focus on solving the system of two equations, which should not be a big issue, right? Because we can quickly solve for either x or a y. Let's solve for y. 48 minus x. Take that, plug in for y, get 12x plus 5 times, now we have 48 minus x over here, equals 450. That's the same equation, except we use the substitution, right, to deal with this. And now we go and we solve the equation. So 12x plus, now 48 times 5, we need to multiply that. That's 240 minus 5x equals 450. 12 minus 5 is 7x plus 240 equals 450. 7x is equal to, when you take away 240 on both sides, you get 210. And when you divide by 7 on both sides, x is equal to 30. So the first exercise took 30 minutes. So now we need y. Well, luckily we know that total time was 48 minutes. So when you take away 30 minutes, that means you were 18 minutes on that stationary bicycle getting nowhere, right? So we will just write the sentence that the student spent 30 minutes on what was that? Thread climber. And 18 minutes on the stationary bike. Now, this is an answer, but it's not just the times that they want. They also want to know the number of calories burned with each exercise. And we have the rates. We know that the thread climber burns 12 calories per minute. So if you were 30 minutes on the thread climber times 12 calories per minute, that means you burned 360 calories while on the thread climber. Stationary bicycle burns 5 calories per minute. You were on stationary bicycle 18 minutes times 5 calories per minute, and then 5 times 18 would be 90 calories. Now, you can also here use the check. When you add them, you see that this is 450 calories burned in total, which is what the problem said at the beginning. So the particular problem can be used to compare two different things. How much time you spend studying one class versus another class, right? The topics and doing the homework and so on. You have seen here the exercises. You can also think about running and walking. You can also do, I don't know, running then swimming, let's say. Maybe you are traveling by a train and then by a bus or a car and a train for commute, for work. You can also figure out the prices. You can figure out the times. Anything current that we can do. Figure out, I mean, a whole bunch of things that can be done this way. You just need to be able to sort the information into the chart and then pull the information from the chart and have it done. And that's it. So you have seen the systems of equations, the solutions to the systems. You have seen the word problems associated with all of this. And I will post the homework. This ends chapter 4 because only 2 sections in there. And we are ready to talk and think about the exam 2, which would be posted in my math lab. Now, we'll have to figure out the time. It will be on chapters 3 and 4. And what I'm going to do, please pay attention here, is I'm going to keep the test open from noon to next day noon. So if you want your exam to be on, let's say, Thursday next week, let's say, so, or whatever day, doesn't matter, day is a day. Online is always open. We can have an exam which opens at noon, and whenever you start the exam, the timer for the test will start. So the exam will be hour and a half, 10 questions as usual. And then when the time is up, the exam will automatically close and submit whatever you have done up to that point. So you can go and deal with exam at any point during the day or night. But remember that it will start counting when you start the test. That's when it starts counting 90 minutes. So if you start at 7 p.m., you're done at 8:30. If you start at 1 a.m., you are done at 2:30 a.m., right? So it will count, and then you will not be able to access it again later, and so on, once you submit, once you're done. Now, guys, if you start your exam at 11:30 and the test closes at noon, then you will only have 30 minutes, so you need to take it right earlier. Now, we did not set any dates yet. We did not talk about any of that stuff, but unfortunately, the way the situation is, we have to have these exams on my math lab. So I'm going to post all of the homework for you guys. I'm reopening chapter 3 and chapter 4 will be available, so you can practice, and then we can see maybe sometimes next week we can run through the exam and see how that goes online. And by the way, this is unfortunately it for the rest of the semester. We have everything done online now because it is the school is officially closed all the way through the end of the semester, and they are also pushing commencement at some point, rescheduling. So we'll have to deal with all of that mess as we go on. All right, I will see you all next time. Regular time, regular class time. I will be streaming, and if you guys have questions, just shoot them over. See you all.